Kashish is not there. खुशी सानेपरा. खुशी,
यस सर.
तो तुम कहाँ हो खुशी?
भावनगर में.
कहाँ?
भावनगर.
भावनगर. तो तुम्हारी आवाज इतनी दबी हुई से क्यों है? आर यू क्वाइट फार अवे फ्रॉम योर कंप्यूटर?
नो.
तुम्हारी आवाज ही ऐसी है.
नहीं.
तो कितने भाई बहन हो तुम?
मैं एक ही हूँ.
अकेली हो तुम? अच्छा. और पेरेंट्स क्या करते हैं खुशी?
फादर डॉक्टर है
पेरेंट्स
और
तुम्हारे क्या?
मम्मी हाउस वाइफ.
मम्मी इज होम मेकर एंड फादर इज डॉक्टर. और उनका क्या स्पेशलाइजेशन है?
फादर का पैथोलॉजिस्ट.
पैथोलॉजिस्ट है. तो उनका अपना पैथोलॉजी सेंटर है या किसी पैथोलॉजी सेंटर में काम करते हैं?
नहीं, अपना है.
अपना है. तो अभी तो बहुत उनको काम होगा ड्यू टू कोविड. कोविड का टेस्ट करते हैं? आरटीपीसीआर वगैरह है उनके लैब में?
नहीं.
अच्छा, नहीं है. Okay. How to approach dean as SBG said no chance of lecture at campus? चैट पे कोई मैसेज डाला है. At campus even if you have any problem at home. अच्छा, मैंने तुम लोगों को प्रॉमिस किया था कि मैं एसबीजी से आई विल हैव अ वर्ड विद देम. वो मैंने मेरे आई फॉरगॉट. मैं नोट आज कर ले रहा हूँ. एसपीजी से एक बार मुझको बात करने दो. एक लड़के ने एक मैसेज किया है. आई एम रिस्पॉन्डिंग टू दैट मैसेज. दैट स्टूडेंट इज कमल पटेल. तो एसबीजी से मैंने नोट कर लिया है. मैं एसबीजी से पहले बात करता हूँ. देन आई विल सी हाउ टू अप्रोच दिस इशू. बहुत इजीली सॉल्वेबल नहीं है के लिए. तो आई विल गेट बैक टू यू. व्योम पटेल. व्योम पटेल. अच्छा, व्योम एक एमटेक का लड़का है जो इसमें टीए भी है. आर यू द सेम व्योम? व्योम पटेल.
नो सर.
हाँ व्योम, तुम बीटेक वाले हो या एमटेक वाले हो?
सर बीटेक वाला हो.
अच्छा, क्योंकि व्योम नाम का एक लड़का टीए भी है ना एमटेक का. आई थॉट दैट ही इज अटेंडिंग माय क्लास.
व्योम शाह है शायद
वो व्योम शाह है. राइट. प्रार्थी देसाई. प्रार्थी.
क्या? हेलो सर, गुड आफ्टरनून.
हाय, गुड आफ्टरनून प्रार्थी. तुम कहाँ हो?
वलसाड.
वलसाड. और तुम कितने भाई बहन हो?
2. I have a younger brother.
किस क्लास में है वो?
He is currently in 11th standard, 11th science.
ओह, ये 11th 12th वालों का तो बड़ा ट्रेंड है. चक्कर में हम लोग इतना एक्सपेरिमेंट करते हैं 11th 12th पे. क्या कैरियर बनेगा उनका, क्या कहाँ जाएंगे. So is he interested in medical or engineering or general?
Actually, he is currently pursuing JE, but he is more interested into flying.
Flying यानी plane flying or kite flying?
Yeah, no, sir, plane flying.
Plane flying. तो पायलट बनना चाहता है.
हाँ.
हाँ, आजकल तो काफ़ी अपॉर्चुनिटीज़ हैं, काफ़ी अच्छे ट्रेनिंग कोचिंग सेंटर्स भी हैं उसके, बट दोज आर
But
कॉस्टली.
it's very expensive. Yeah.
बट वेरी गुड कैरियर ऑप्शन, वेरी गुड कैरियर ऑप्शन. तो एजुकेशन लोन लेके तो कर ही सकता है ना. हमारे पिताजी क्या
हाँ.
करते, पेरेंट्स क्या करते?
Actually, my dad is a proprietor for a Reliance petrol pump.
पेट्रोल
So
पंप के मतलब ओनर हैं.
no,
प्रोप्राइटर का क्या
no.
मतलब हुआ?
Proprietor मतलब company pump है, but he operates it. He is responsible for it. ऐसा. He is a salaried employee.
ओह, तब तो मजा नहीं है.
हाँ. ओनर तो फिर प्रॉब्लम क्या थी फ्लाइंग में. No, but we'll figure out something like we once he's sure enough of what he wants to do.
अब और बेचारा कितना श्योर एनफ होगा.
नहीं, बट वो ऐसे बोल नहीं रहा ना कॉन्फिडेंटली कि उसे ये करना ही है. ही इज जस्ट ट्राइंग टू से कि मतलब ये ऑप्शन इज समथिंग ही इज इंटरेस्टेड इन. ही इज नॉट रिसर्चिंग कि कैसे करना है, क्या करना है. तो फिर
बट लेट मी टेल यू, दिस इज अ वेरी गुड कैरियर ऑप्शन दीस डेज, वेरी गुड कैरियर ऑप्शन. तो अब तुम्हारे पिताजी की रिस्पॉन्सिबिलिटी है उसको ये कहना कि अगर करना चाहते हो तो आई एम विद यू एंड वी विल मैनेज फंड. दैट्स इट. और
या
कुछ
दैट
स्किल नहीं चाहिए, और कुछ स्किल नहीं चाहिए. इसमें आपको केवल नंबर ऑफ फ्लाइंग आवर्स विल काउंट टू बिकम अ पायलट. दैट्स इट. एक देखो कोई लिख रहा है, तो दर्शन गोयल लिख रहा है, इंडियन एयरफोर्स इज अ गुड ऑप्शन. राइट, एयरफोर्स सर्टेनली इज अ गुड ऑप्शन. उसके लिए उसको एनडीए देना पड़ेगा, एनडीए करके वो जा सकता है. रादर दैट इज अ बेटर ऑप्शन. इसमें आपको थोड़ी इज्जत भी ज़्यादा है, मतलब इज्जत यानी पीपल विल नो, पीपल विल रेस्पेक्ट यू.
अग्रीड.
तो एनकरेज हिम, एनकरेज हिम. सब लोगों का
Yes.
इंजीनियर बनना जरूरी नहीं है.
Sure, sir. Yeah.
सब लोगों का इंजीनियर बनना या डॉक्टर बनना जरूरी नहीं है. मैं तो ये कहता था इस जमाने में जब मेरे बच्चे 10th 11th में जा रहे थे, तो मैंने कहा था कि यार इंजीनियरिंग में मीडियोकर्स आते हैं, क्योंकि वो बहुत इजी गोइंग फील्ड हो गया है आजकल. कोचिंग कर लीजिए तो रीजनेबली गुड रैंक आपको आ जाएगा. रीजनेबली गुड रैंक आने पे रीजनेबली गुड इंस्टीट्यूशन में आप जाइएगा. और जो मैंने, अगर तुम लोगों को मैंने ईडीडब्ल्यू में बताया होगा, जो फर्स्ट वो जो बताया,
Yeah.
तो वो वही हम लोग
जेन पेंसिल.
राइट, जेन पेंसिल का. वेरी गुड.
हाँ.
याद तो रखे हुए हो तुम लोग. ग्लैड. तो हम लोग वही रैट रेस में चले जाते हैं, विच इज नॉट नेसेसरी. रादर वी शुड ब्रेक दैट ककून. ठीक है, बट ये मैं नहीं कह रहा हूँ कि तुम लोग अगर इंजीनियरिंग में हो तो गलत कर रहे हो. बट इफ somebody has something different, then we should try to encourage that person. Okay. ये बताओ कोविड का क्या हाल है तुम लोगों. Since you are healthy, therefore you are joining my class. But और क्या आपके फैमिली में are everybody okay, not okay, some help?
So currently, so everything is okay. Touch wood. Yeah, there like some viral infection is also quite very robust here in Valsad because the weather is changing like anything. Today it's too cold. It's not even a like दो स्वेटर पहन के lecture attend करना पड़ रहा है. And
ऐसा है.
exactly though like it's like that from 2 days and then it was very sunny the other day. So that's the reason why a lot of people are having cold and cough. But otherwise, it's pretty good. It's getting better than what it was a few days back.
हाँ, और अभी क्या है कि कोल्ड एंड कफ होते ही लगता है कि इसको कोविड हो गया,
हाँ, कोविड है.
क्योंकि दिस टाइम कोविड के फीचर्स डिफरेंट आ रहे हैं.
इवन इन सम केसेस मतलब वायरल में पॉजिटिव डिटेक्ट हुआ है, ऐसा भी हुआ है. लाइक डॉक्टर, फैमिली डॉक्टर ने ऐसा बोला कि अभी मत टेस्ट करवाओ इफ यू डो नॉट हैव फीवर फॉर 1 or 2 days, लाइक हाई फीवर, क्योंकि it's not showing as accurate result as it was showing before.
गुड 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 गुड. लेकिन ठंड की ऐसी बुरी हालत है, मैं तो
Actually,
देखो शर्ट में बैठा हुआ हूँ.
actually, I guess one reason is that there was some kind of storm or something. Like it rained 2 days back here. And second thing is that I live in a village, so I live in like a lot of greenery. ऐसे आम के बागीचे हैं आसपास, तो that adds on. That adds on a lot.
ये आम जो है उधर का सूरत वाला जो हापुस या क्या कहते हैं वो,
Yeah, हाँ,
ऑर्चार्ड,
वो
तो उसके कंपटीशन में
वो
रत्नागिरी
सूरत का नहीं
अल्फांसो.
होता है सर, वो वलसाड़ का ही होता है.
हाँ मतलब
वो
मैं
सूरत
उतना प्रेसाइज मेरा सैटेलाइट मैपिंग नहीं है. हाँ,
सूरत
उसी एरिया
does
का है
not. हाँ, हाँ.
जो रत्नागिरी वाले अल्फांसो का कंपटीशन में सुनता हूँ. मैं कभी खाया नहीं हूँ हापुस भी. ओके.
मैं खिला दूंगी सर अगर कॉलेज खुल गया तो.
हाँ
मेरे
तो
घर के
खुलवाता
ही
हूँ.
है.
अच्छा, या कभी मैं वलसाड आऊंगा समर में तो खाऊंगा.
पक्का.
ओके प्रार्थी, नाइस टॉकिंग टू यू. एक लड़का
Same
है
here,
कमल
sir.
पटेल, द सेम गाय कमल पटेल. कमल, क्या तुमने कमेंट लिखा है? मैं समझा नहीं. कमल,
अरे सर वो
you have
ग्रुप
written
की जगह
something on chat.
गलती से यहाँ हो गया.
सॉरी, बोलो.
नहीं सर, मतलब आप करियर गाइडेंस दे रहे थे ना कि
हाँ
इंजीनियरिंग मतलब.
हाँ, नहीं, यू हैव रिटन आई एम लीविंग इंजीनियरिंग एज एवरी इंजीनियर डू. So what do you mean? As every engineer leaves engineering?
यस सर, आई थिंक यूट्यूब ज्वाइन करते हैं, ये सब करते हैं. इंजीनियरिंग तो कहाँ होती है हमारे.
अच्छा, सो फिर इंजीनियरिंग का क्या इमेज है तुम्हारे दिमाग में? That is a question then.
ऐसे इंजीनियर मतलब कैसा होना चाहिए, परसेप्शन हमारा ऐसा.
हाँ, परसेप्शन क्या है तुम्हारा? That will answer your question. ये कौन है? प्रणव पाटिल. प्रणव प्रणव पाटिल प्रणव,
यस सर.
तुम क्या स्माइली थ्रो कर रहे हो? क्या कर रहे हो तुम?
सर वो नाम आ रहे थे तो उसमें वो गलती से स्माइली वाला दब गया. वो मैं निकाल रहा था, उसे बंद कर रहा था तो दब गया वो.
अच्छा, so you want to smile on our discussion?
यस सर, इट्स फनी आल्सो.
Okay,
नथिंग रॉन्ग.
good, good for appreciation. But for Kamal and everybody, you have to define or you have to redefine what engineering is, and then you can find satisfaction in that profession. So ठीक है, इस पे माने ये फिलोसफिकल डिस्कशन है, तो अभी इसको मैं आई वुड लाइक टू एब्सटेन. अब हम लोग अपने पढ़ाई पे आए. इट इज 12:15. So let me here एक वीडियो भी दिखाऊंगा. आ गया कर्सर यार. share. Okay, or let me start recording. Let me stop my video. Start recording. And this. So, is my screen visible to you all?
Yes, sir.
Okay. So this is a standard first slide, which I will keep for 1 or 2 more weeks. Then I will remove this. On this, every information is there. Now, what are the links, and what is the timetable for this, and what is the Moodle link? I hope that most of you have joined Moodle. Those who have not, please join that. And I will keep posting all the lecture slides. So PDF file of my presentation, as well as the videos, link for videos. I will put there so that you can refer to those videos also, what I have taught in the during the class. These 4 people are the TAs, their email address, and therefore their IDs are also given to you. In case of any requirement, need, any support, help, you may write to them. But these people are even less familiar with the institute than you. तो बहुत ज़्यादा वो support नहीं कर पाएंगे. As far as this course is concerned, again they might not be in a position to support you. So the best way to get a support or to reach to is to write to me. But ज़्यादा परेशान मत करना मुझको. I did ask for some volunteers from your batch who would like to represent. So I received quite good number of responses from you. I have to announce whom I have selected. Maybe I will select all of them, because I think that I received around 10 responses from your batch. So all 10 students I will keep as your class representative. So you may approach them also for your any genuine or ingenuine demands. So don't hesitate in demanding what you want. Let me decide whether it is acceptable or not acceptable. और जब तक बताओगे ही नहीं, मेरे तक बात नहीं पहुंचेगी, तो मैं उस पर कुछ नहीं कर सकता. So certainly don't hesitate in writing to me or to reaching out to me through your class representatives. Don't ever think twice. Just write to me. Okay. So this is the final grading policy that I am giving you: quiz, mid-sem exam, end-sem exam, term paper. It may be revised subject to situation, what will remain in or what will appear in this semester. तो अगर पेंडेमिक का सिचुएशन वर्स होता है, तो हो सकता है कुछ कंपोनेंट में हटा दूं या उसको डाइल्यूट कर दूं. डिपेंडिंग अपॉन द सिचुएशन, we will take the call or we will revise. But certainly at the time of revision, I will get back to you. I will contact you, and with your consent only, we will decide what is the standing grading policy for this course during this semester. Okay. So that is my gentle promise with you. मैं एक काम ये कर सकता हूँ कि I will assignment मैंने हटा दिया है. Assignment is beyond my capacity, so I have removed assignment. But what I will do is that I may give you some suggested assignments. इसको मैं evaluate नहीं करूँगा, but I will give you some questions which will help you in learning the course material or the subject material rather, which will certainly help you in your exam performance. तो जो अटेंटिव लड़के हैं, जो कुछ अच्छा करना चाहते हैं इस कोर्स में, those suggested assignment problems will help you in improving yourself. ठीक है, वो आप लोग खुद बनाइएगा, वर्कआउट कीजिएगा, मुझको भी भेज सकते हैं अगर मुझको टाइम मिलेगा तो आई विल सर्टेनली मेक अ कमेंट ऑन दैट. आई विल सर्टेनली, इफ आई फाइंड समथिंग रॉन्ग in your approach, I will ask you to correct that, but grading में नहीं रखूंगा उसको. Okay, और so this is about grading policy, which is final, and therefore I am keeping this on the slide for our record. So now let us begin our real semester course. So in the last class, perhaps in the last slide, this was the discussion that we were engaged in. The discussion was that if you go to a display technology, so if you join Samsung, why this course becomes important for you. If you join Qualcomm, how this course is going to help you. So that is the relevance of this course, on the basis of which we thought that this course should be introduced as a core course for BTech guys, and which should fall in the 4th semester. So this is to recall or to join you with where we left in the last class. So for display technology, certainly we are going to understand what is quantum dot as a novel material, how quantum dots are used in today's display technology for TV or for your mobile display, mobile phones, or your laptops, computers. So this quantum dot, so while studying quantum dot, what is LED display, what is LCD display, all those will be referred to, or all those will be mentioned and maybe discussed briefly about. Similarly, for communication technology, what are the material that we use depending upon the application? So you might be reading, hearing about, or you might be curious to know about the materials which are going to rule in the coming era of 5G technology. Researchers have also started working in the direction of 6G. So what is 5G, what is 6G, how materials are going to impact, what is gallium arsenide, and how gallium arsenide and gallium nitride are different. So what is 3,5 material? Because the typical semiconductor material belongs to group 4, so silicon, germanium, that we know. But there is another class of material which is called 3,5. Gallium arsenide, gallium nitride, they belong to this class of material. Even among this class of material, like silicon is different from germanium. Silicon is used in different situations. Germanium is used for different applications. Similarly, gallium nitride has a different application, different domain for use, where gallium arsenide may be performing inferior to gallium nitride. So this type of discussion on material we will have during this semester. This is just a glimpse or to excite you that you are not at a wrong place. So that we will be doing during the semester. Okay, so this slide I am again showing that the best driver to find out novel material for human being, for us as engineers, is nature. So nature always gives us such a splendid examples of surfaces, material, applications that we are amazed. We are amazed. And this is one typical and beautiful as well example of how nature responds to humidity. So why dew is formed only on certain surfaces? अहमदाबाद में मुझको ड्यू नहीं दिखता है. अहमदाबाद जहाँ जिस locality में मैं रहता हूँ, so because of the concrete structure we don't find dew here. But maybe अभी जो ये प्रार्थी जो बोल रही थी कि उसके मैंगो ऑर्चार्ड में she might be finding आजकल जब विंटर सीजन में she might be finding a good amount of dew. So what is the difference? What is the difference? क्योंकि human being has not done anything specific in Valsad than in Ahmedabad, but nature has created something peculiar which makes some place favorable to dew formation, some place favorable to more moisture content, concentration. Some places are desert. Some places have big rivers flowing through them. Some places have ice. So taking a clue from nature, let me first give you a very typical example of maybe some of you might be familiar with this property of bamboo, but for many certainly this is going to be an eye opener that stop sharing. Again, I have to ये क्या किया मैंने? Share my screen. Then I have to go to that movie.
Thank you.
So is it visible and audible both?
Thank you very much.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay, thanks.
That is beautifully engineered. That, to produce it, will consume minimal energy.
So this is a TEDx talk,
That actually
not a TED talk. This
sinks
is a TEDx talk.
carbon dioxide.
This person is giving a talk
And it
in a
simply grows.
university
We don't have
on
to
the
manufacture
properties
it.
of bamboo.
And we can harvest it in 3 to 5 years. And in the process, it will employ millions of people in rural communities in the developing world. And it's very cheap. There is material. It's bamboo. Bamboo has thousands of applications, which range from paper, kitchen utensils, floorboards, clothing, and even allegedly, the bristles in this toothbrush contain bamboo-derived charcoal. However, speaking as a structural engineer, what fascinates me about bamboo is just in its natural shape. As I said, it's beautifully engineered. Take its shape. The fact it's hollow instead of solid makes it 4 times more efficient. Its nodes, concealed diaphragms, they stiffen the walls of the element so it buckles less. It's less likely to buckle. And they're closer together where they're most needed. Its fibers are 3 times stronger than structural steel, and they're very cleverly distributed. For example, in the wall, they're concentrated towards the perimeter, making the section 10% more efficient than if they were just randomly distributed. You might be asking, well, yeah, that sounds interesting, but how does that compare against man-made materials? So let's do like a thought experiment. How much would this piece of bamboo take? What would be the maximum safe working load of a 3-meter beam made out of bamboo? And that would be roughly around 290 kilograms. So now, how would that compare to, say, steel? Well, if we limited ourselves to commercial sizes of steel, a steel section that would achieve the same safe working load would be about that size, which is smaller, you'll say. So it's not a very fair comparison you're going to do, David. Let's do something a bit more comparable. So I've dreamt up a size that you can't buy. You'd have to have specially made, but there's no reason why we can't assume it, which would be this size, 84 mil diameter. So how do they compare? How do these materials compare? So in terms of mass, the hypothetical steel section would weigh around 7 kilograms. The commercial one, the one that we really can buy, would weigh around 10 kilograms. Whereas the bamboo one would weigh just short of 6 kilograms. So in terms of strength to weight ratio, bamboo is as good, or if not better, than steel, which is pretty impressive. However, what really matters is cost. And the currency I'm going to tell you about is carbon dioxide. So, the carbon emissions associated with making these sections would be around 10 kilograms for the hypothetical steel section, around 15 kilograms for the commercial size section, and if this bamboo is used within 500 kilometers of where it was sourced, it would be just 1 kilogram. So that's really a substantial difference in terms of efficiency. However, there's more. This piece of bamboo stores within it around 10 kilograms of carbon dioxide, or the equivalent of. That means, considering the 1 kilogram we use to process it, that we're storing, or we're capturing from the atmosphere, 9 kilograms of carbon dioxide. Which means that if I choose to make this a beam out of bamboo instead of steel, we would be making a saving of around 19 kilograms of carbon dioxide. That equates to the emissions produced by an average European car over 150 kilometers. Now, this carbon storage only remains there for as long as that piece of bamboo is in a permanent structure. But say if 50 years down the line we demolish this structure and then we burn the bamboo, we go back to this situation because the 10 kilograms will return to the atmosphere. It's still better than steel, but not as good as this. So, however, if we burnt it and generated electricity, for example, and in the process avoided burning a fossil fuel, which would introduce new carbon dioxide to the atmosphere, it would be sort of the equivalent of making this storage permanent. Now, if there was someone from the timber industry here, they would say, hang on, that's true also for timber, and it is. However, bamboo has one key difference with respect to timber, is that it takes 3 to 5 years to be harvested. It only takes 6 months from the moment it emerges to reach its full height, up to 20 or 25 meters. So, in the war against carbon emissions, bamboo is a weapon that we can deploy sooner. And bamboo has other environmental qualities. For example, its forests have a complex root network that control erosion and regulate the water cycle. And by the way we harvest it, in which we only extract some of the mature culms, in the forest, wildlife can find sanctuary. One of the great challenges of the 21st century will be the urbanization of the developing world. It's estimated that 2 billion people are going to be moving to the cities over the next 30 years. And in the process, huge carbon emissions will be made associated with building the houses, the schools, the roads, and the infrastructure that this will require. Many of these countries are in the tropics, and they can and they do grow bamboo. In fact, it's estimated that 1 billion people live in bamboo housing across the world. Not this sort of bamboo housing, nor this sort of bamboo housing, which in fact is an office building. More like this. And it's very likely at some stage in their life they will aspire to upgrading. And very likely they'll upgrade to something like this, a concrete masonry and steel house. However, if we could persuade 100 million families around the world to move into a bamboo house like this one, and if each one of these houses consumed the equivalent of 4 tons, which is quite modest, of bamboo and bamboo-related products, we would sequester from the atmosphere the equivalent to 500 million tons of carbon dioxide. And it's likely we would also avoid the emission of another 500 million tons from making all the concrete and steel and bricks that would normally be used. 500 million tons of carbon dioxide is approximately the total greenhouse gas emissions of the UK in 1 year. However, to achieve this, things have to change. We have to make bamboo mainstream. But unfortunately, there isn't enough research into bamboo, which affects the development of codes and standards, which results in that architects and engineers do not design enough with bamboo. They don't specify it, which affects then demand. And because there's perceived to be no demand, researchers are not interested in bamboo. So we somehow have to break this vicious circle. We have to start researching it a lot more, so that we can develop the codes and standards that will then empower.
Come back to. So is this slide now visible to you?
Yes, sir.
Yes, sir.
Okay, thanks. So let us spend 1 or 2 minutes on this video. I spent almost 12 minutes on that for 2-3 particular regions. One, that bamboo is comparable to steel. And that is certainly, if you are not aware of that, then this is an amazing fact for those who are not aware of this fact. But on top of that, I want to excite you towards the end of this video, which we were listening right now, is that how we can excite or impress upon or impact or create a sensation, awareness among people to use such type of material which is environment friendly and which is actually giving us more benefit than making our than bringing us out of the box thinking. And while watching this video, I came up with an idea that I may allow you to approach me with some such sort of extraordinary project concept. So like for bamboo, if we want to approach our climate change department or environment and forest department, that let us do a awareness campaign at a state level. Or if we approach pollution control department, is it a department or what? I don't remember. But pollution control department, let us assume. So if we can approach them, that let us have a open house discussion, or let us have a brainstorming session at a state level along with all the stakeholders, that why not think of using some different material which is sustainable, which is environment friendly, which has less carbon footprint, which consumes than generates it. इस तरीके का अगर कुछ ब्रेक थ्रू आइडिया यू हैव एंड यू want to pursue that idea, then I can allow you, if your idea is accepted by me, I can allow that person to pursue that idea, and in lieu of that, that person will be relieved from all other grading criteria. So no mid-sem exam, no end-sem exam, no term paper. You have to work on that project to make it at least visible at beyond your institute level, and you do something outstanding, and I will grade you on your effort on that. So this is, I am going to add in grading policy, that if you are coming up with some outstanding, extraordinary, out of the box idea for doing something based on materials during this semester, which has a long lasting impact or visibility, then I will certainly encourage that student to work with me for or towards that concept. Okay, so let's move ahead. This is one typical example from nature. The left image is the lotus leaf, and this is a typical property of a lotus leaf, because of which spiritually, or maybe not spiritually, religiously, lotus leaf is considered to be one of the purest form, or lotus flower is considered to be the purest flower of all, and we use it for our prayers or our offering to God, whatever. Okay. So what is that property? That property is that lotus leaf self-cleaning and non-wetting surface. Because of its non-wetting, it is self-cleaning rather. So if you can see, observe carefully, you can see that these water drops are residing on the leaf, and with some breeze, some gentle wind, these leaves may tilt in some direction, and thereby these water droplets will slide from this leaf to the pond. While moving from the leaf to the pond, they actually take away all the dust particles coming in the way. And therefore, lotus leaf is also called self-cleaning surface. Okay. So now there are two properties that we are observing or taking example from nature, that a surface can be non-wetting and a surface can be self-cleaning. Okay. On the right hand side, the image that you are seeing is of the same lotus leaf. And this image is on electron microscopy. You can see that the cleanest and the softest surface that you can feel about this lotus leaf is actually made of these tiny nodules appearing on its surface. And these tiny nodules at nano scale is actually responsible for the self non-wetting property of this lotus leaf. So once we go into the detail, this is where engineering appears, or role of engineer appears. That after observing the property of this lotus leaf, we try to mimic that. And the top right image is that mimicry, that we have created a synthetic material showing this lotus effect. The lotus effect is nothing but a non-wetting creation of a non-wetting surface. Based on this lotus effect, there is another concept in Hindu mythology, is the fakir bed. The fakir bed is actually the accepted term worldwide. So in the fakir bed, what is happening is this is that the left image, the cartoon, is that fakir bed. So there are many pointed metal pins which are piercing out of the surface, wooden surface, and a person who is called fakir or saint is demonstrating that he can sleep on that spiked bed without harming his skin or his body. This is a beautiful or laughable image where it is said that there are two bearded fakirs standing watching a young fakir lying on that bed, and they are seeing that the young fakir's body could not bear that pain, or rather those pains are actually piercing inside his body. The comment is that there, what am I always telling you? Young people today are soft. Like we also say that you young generation guys are ... So similarly here also they are facing some competition, and they are finding that the young fakirs are actually not tolerant to this type of situation. But going away from this cartoon strip, now the point is that how a fakir can do that, or how a water drop is on the surface without wetting the surface. So then come back to this situation. The left side is the electron microscopy image of that lotus leaf. The right side image is showing the big sphere, big spherical ball, which you are seeing is actually the H2O molecule or water drop, or rather droplet, not drop, droplet on the lotus leaf. And on that sphere, the dark spots that you are seeing are those dust particles sticking to that water molecule while it is sliding down to the pond from the lotus leaf. So you can see very well how that water drop is staying on the surface of lotus leaf without wetting it. And that non-wetting characteristic or property of lotus leaf is actually defined in terms of the contact angle that it is making with respect to those spikes coming out of the lotus leaf surface. And those spikes are at nanoscale. This theta f is that angle of contact which is going to determine or define when a surface is wetting surface, when a surface is non-wetting surface, or with which type of liquid the surface becomes wetting from non-wetting. So it is the property, or it is the interaction between the liquid drop and the surface that makes the surface wetting or non-wetting. Now, before we go to the concept of contact angle, let us visualize this practical situation. Many of you might be driving or know how to drive, and many of you while driving might have faced such situation that when you were on the highway there was raining, or like somebody just said that 2 days ago there was in Surat, there was it rained in Surat. So when you are driving while raining or in the rain, what do you do or what do you experience? You experience that a fog is created in the inner part of this windshield of the car, and water drops are pouring on the outer surface of the windshield. To clean that or to remove that those water drops or water stream on the outer part of the windshield, you use wiper, right? But what do you do for the inner fog type of situation that is condensed on your windshield? So for that, in many modern cars, on the outside surface, water does not spread. Water drops actually accumulate and fall down with gravity because of their weight. contrast to that or opposite to that, inside is coated by hydrophilic material. Hydrophilic means which attracts water. So the moment some water molecule condenses on the inside surface of that windshield, it tries to spread over, hydrophilic. So it loves water. So water molecules are uniformly spread all over the windshield. It does not trickle down. It does not skid down. It does not accumulate and falls down. Because of this, you see a foggy or hazy surface which restricts your transparency of the glass. Okay, so this is the material that is used in the windshield. Now my question is, what will happen if we reverse this arrangement? Can anybody try to take this question? Reverse this arrangement means inside we make hydrophobic and outside we make hydrophilic coating. नहीं बताओ भाई, मैं वो पढ़ूंगा नहीं, मैं फुल स्क्रीन मोड पे हूं, आई कैनॉट रीड द चैट.
Yes, sir.
Somebody, you have to unmute yourself and answer.
Hello, sir. I am Romy. So when we coated outside with hydrophilic, when it was outside raining, the water droplets will stick with outside surface, and when we start AC in the in inner side of the glass will hydrophobic, and the fog will melt like be water droplets, and will मतलब नीचे की साइड आ जाएगी.
So what is the problem in that?
So अगर बाहर
पानी भर जाएगा और बाहर मतलब वाइपर्स का कोई काम नहीं रहेगा.
Who is
अगर
this?
वाटर ड्रॉपलेट्स
Push.
यस सर.
हाँ बताओ खुश.
अंदर की लेयर मतलब पानी को अट्रैक्ट नहीं करेगी. मतलब इनसाइड अगर हम एसी स्टार्ट करेंगे तो वो कंडेंस होके वाटर ड्रॉपलेट बन जाएंगे, तो अंदर पानी पानी हो जाएगा और बाहर की तरफ मतलब जो वाइपर्स है उसका कोई काम नहीं रहेगा, क्योंकि वाटर तो इकट्ठा हो ही नहीं रहा, तो वो किसे डालेगा, मतलब स्प्रेड होगा वो.
Any other answer?
सर वाइपर की जरूरत तो है, क्योंकि ज्यादा बारिश हुई तब तो पानी कॉन्स्टेंटली ऊपर गिर रहा होगा तो हमें कुछ दिखेगा ही नहीं, तो वाइपर तो चाहिए ही.
वाइपर चाहिएगा, बट अगर बाहर की साइड मतलब नॉर्मल ग्लास होता है, अगर उस पे पानी गिरा हो तो हम कैसे पोछा मारते तो भी छोटे छोटे ड्रॉपलेट्स रह जाते हैं और वो एकदम सीधा देख सकते हैं, ऐसा नहीं रहता, धुंधला सा जैसा हो जाता है ऐसा. तो अब एक्सीडेंट के चांसेस बढ़ जाएंगे. वो तो पहले से भी खराब होगा कि पहले पानी था तो थोड़ा भी दिखता है, जब छोटे ड्रॉपलेट्स होते हैं तो बिल्कुल सही ऐसा होगा.
Any other answer? थोड़ा और केयरफुली सोचो.
Sir, if the outside surface is hydrophilic, then like when the raindrops fall on it, the wind won't be able to blow it away. So like the water will rest on it, on the windscreen, and it will affect the vision.
Any other answer which might be different from this? थोड़ा एक चीज मिस कर रहे हो. रादर यू आर डूइंग क्वाइट गुड, ऑल आंसर्स आर राइट, एक एलिमेंट यू आर मिसिंग.
सर
यस.
सर अंदर की साइड हीटर होगा और बाहर हीटर नहीं हो सकता, इसलिए अगर अंदर अंदर अगर हाइड्रो हाइड्रोफोबिक है तो हम हीटर नहीं, अंदर अगर हाइड्रोफिलिक है तो हम हीटर चालू करके काम कर सकते हैं, पर अगर बाहर होगा तो बाहर हीटर नहीं होगा, तो हीटर शायद एक एलिमेंट हो सकता है।
एनी अदर आंसर? ओके, मैं हिंट देता हूं, सोचना। मैं आंसर नहीं बताऊंगा बिकॉज आई ऑल्सो डोंट नो व्हाट इज द आंसर। द हिंट इज व्हाट आई कुड थिंक डिफरेंट फ्रॉम यू इज, जो बाहर का वाइपर है, देयर इज अ रबर मटेरियल दैट इज देयर इन द वाइपर, ठीक है, जो पानी को वाइप आउट करता है। सिंस आउटसाइड इज हाइड्रोफोबिक, the all condensed part of water is also getting converted into water drops, and therefore there is a volume that rubber material is wiping out. But think of the situation, this rubber material is certainly not over the glass completely sticking to that. पॉसिबल ही नहीं है। अगर बिल्कुल स्टिक करेगा तो फ्रिक्शनल फोर्स इतना ज्यादा लगेगा कि वो मोटर उसको रोटेट नहीं कर पाएगा। So that rubber material is not exactly forcefully sticking to the glass top of outside glass surface, but because of hydrophobic nature of the coating, it is drifting or it is removing all the water drops over that surface. तो ठीक होगा वो। So certainly a micron thickness of water layer will always stick, will always be there on the surface, which will restrict your clear visual requirement. अंदर की बात किसी लड़के ने ठीक ही की, अंदर अगर हाइड्रोफोबिक है और वो वाटर ड्रॉप बन के वो नीचे गिर रहा है तो आपका पूरा डैशबोर्ड विल गेट एंड दैट विल डैमेज द इलेक्ट्रो, क्योंकि डैशबोर्ड के नीचे बहुत इलेक्ट्रॉनिक्स है। So there are many PCBs which are there just below the dashboard. तो वो आपका इलेक्ट्रॉनिक्स को डैमेज करेगा, इरोड करेगा। So okay, so you were on the right direction, but still as an engineer you need to think slightly more deep or in a different way. Okay, so let's do this experiment. Take a newspaper sheet and a glass piece. दो मटेरियल हम लोग ले रहे हैं, एक न्यूज़पेपर ले रहे हैं और एक ग्लास शीट ले रहे हैं। दोनों के ऊपर एक एक ड्रॉप पानी का डालो, जस्ट वन ड्रॉप। तो मान लो ग्लास पीस के लिए तुम अपने मोबाइल फोन का सरफेस रखो और पेपर तो आपके घर आता ही है, when you can do it right now or immediately after the class. दोनों के ऊपर जस्ट एक एक ड्रॉप पानी का डालो। So what do you observe?
Sir, the water will wet the newspaper sheet and it will just stay on the glass sheet. Because
right. So newspaper sheet, newspaper का जो surface है, that will soak, that will immediately soak, disappear. But that will remain, stay on the glass surface. अब ये क्यों होता है? Its answer is given. Its answer is given. ठीक है. Its answer is given on this slide. If you recall your 10th, 12th standard physics lessons, then you would remember कि वहाँ हमने मेनिस्कस की बात की थी। क्लास में किसी भी एक पॉट में अगर हम वाटर रखते हैं तो मेनिस्कस कैसा बनता है, अगर हम ऑयल रखते हैं तो मेनिस्कस कैसा बनता है, ग्लिसरीन रखते हैं तो मेनिस्कस कैसा बनता है, when this is flat, when this is rounded but inside round, when it is upside round. तो अलग अलग तरीके का meniscus is found, and that formation of meniscus was defined in terms of force that is called surface tension, and because of surface tension there is a capillary action that takes place, right? तो ये सारी चीज अगर तुमको याद है, then you can understand very well that why a surface can be wetting surface, non-wetting surface, what is how we we differentiate between a wetting and non-wetting surface. So when I keep water or a liquid in a pot, or let us assume in a beaker, there are three forces that we observe based on the surface tension. The surface tension is force, and that is because of the three sets of interfaces. So sets of surfaces which are creating interface between those two surfaces. Okay. One is the one first set is solid and vapor. तो तुम्हारा जो ग्लास का सॉलिड है ग्लास, और वेपर जो एटमॉस्फेरिक वेपर है, या वेपर दैट इज क्रिएटेड बिकॉज ऑफ दैट लिक्विड और द ऑयल और वट एवर यू आर यूजिंग, उसके कारण जस्ट ऑन द टॉप ऑफ द लिक्विड सरफेस जो वेपर क्रिएट हो रहा है वो वेपर है. तो सॉलिड और वेपर के बीच में एक फोर्स लग रहा है, सॉलिड एंड लिक्विड के बीच में एक फोर्स लग रहा है विच इज टचिंग द सॉलिड, योर ग्लास और योर पॉट और योर बीकर सरफेस. तो बीकर सरफेस और लिक्विड के बीच का जो इंटरफेस है दैट इज सॉलिड एंड लिक्विड, एंड देयर इज एन इंटरफेस बिटवीन लिक्विड एंड वेपर. तो पानी अगर लिए हो तो पानी के सरफेस के जस्ट ऊपर उस वाटर का वेपर है. सो वाटर एंड वाटर दे आर आल्सो इंटरैक्टिंग, दे आर three types of interfaces with different forces, and that balance of the force is shown in this diagram. So one highlighter लेता हूँ. So if we take this as our center, then there is one force that is in this direction, जो यहाँ मैंने बनाया हुआ है. इस डायरेक्शन का जो फोर्स है दैट इज बिटवीन द इंटरेक्शन, बिकॉज ऑफ द इंटरेक्शन बिटवीन सॉलिड एंड वेपर. यहाँ पे लिक्विड नहीं है, लिक्विड ड्रॉप ये है, दिस इज द लिक्विड ड्रॉप. So this side is the force or surface tension experienced between the interaction of this solid and the vapor. So SV, solid vapor, gamma is the coefficient of that interaction. Fine. This tangential line is drawn tangential to the liquid drop is between liquid and vapor, क्योंकि यहाँ लिक्विड और वेपर के बीच में इंटरेक्शन है. एंड दिस which is going left is between liquid and solid. So SL, solid and liquid, gamma, coefficient of interaction. So coefficient of interaction between solid to vapor, so right side वाला, ये certainly should be balanced. जहाँ पे बैलेंस होगा उसके बाद वो वाटर वहाँ पे या लिक्विड विल स्टे देयर. So must be balanced by this solid to liquid and a projection of liquid to vapor in this direction. So that projection is cos theta element of this line, right? So this is not a big deal. This equation is a simple equation which anybody can understand very easily. This angle theta is actually the contact angle, right? The contact angle between the solid and liquid. So if this contact angle between solid and liquid is more than 90 degree, then the surface is called non-wetting or poor wetting surface. If this angle of contact is between 0 to 90 degree, then we call it wetting surface. And if this angle theta is 0, so the liquid is completely spread over the whole surface, solid surface, then it is complete wetting. It is complete wetting. जैसे कपड़े पे तुम पानी डालो और वो भी कॉटन क्लोथिंग पे पानी डालो वो डिफरेंट बिहेव करेगा, और टेरी कॉटन पे डालो वो डिफरेंट बिहेव करेगा, टेरी लीन पे डालो वो डिफरेंट बिहेव करेगा, जस्ट बिकॉज द change in this contact angle theta between that theta is defined the angle between solid and liquid, and therefore this is solid and this is liquid, so this angle is this angle, not this angle. ये एंगल नहीं है, एंगल है जो which is completely overlapped by the liquid. You may argue that in this direction also there is solid and liquid, angle between solid and liquid, but this is not solid and liquid, this is solid and vapor. Solid and liquid is in this side, which side is completely overlapped by liquid, and therefore this is the angle theta which we are measuring, and in this case you are seeing that it is just above 90 degree, so it is 95 degree, and therefore the surface is poor wetting surface or non-wetting surface. The bigger the angle, the more non-wetting property appears on the surface, and that is why the lotus leaf is a non-wetting surface, because in case of lotus leaf the angle is more than even 150 degree, and that is perfect example of non-wetting surface. In case of newspaper sheet, that is too small, so it might be 5 degree, 7 degree, 10 degree, and therefore it is immediately disappears. On glass, this theta is more than 90 degree, so it stays on the surface. So basically, based on this definition of contact angle and how surface rules this property of wetting, determines which surface will be wetting, which surface will not be wetting. Now, how we are going to use this property of surface for creating an engineered material? Anybody would like to take this question? How we can take lead from this property, natural property of contact angle, we can make a synthetic clothing so that we can make that cloth a non-wetting cloth or self-cleaning cloth.
तो सर जो वेलवेट कपड़ा होता है ना उस टाइप का, मतलब उसके वेलवेट का कपड़ा होता है उसके ऊपर छोटे छोटे जो मतलब सरफेस एकदम स्मूथ नहीं होती, ऐसा होगा तो जैसे ये लोटस के लीफ में जो स्पाइक्स है उस टाइप के ही उसमें भी स्पाइक्स हो गए तो वो तुरंत गीला नहीं होगा ऐसे।
राइट, तो वो तुमने एग्जांपल दिया वेलवेट के कपड़े का, बट सपोज you are hired by a cloth company, let us say Arvind Mills, जो Levi's jeans का मटेरियल बनाता है, फैब्रिक बनाता है, राइट। अब अरविंद मिल्स में जब तुमने ज्वाइन किया तो तुमको तुम्हारे बॉस ने काम दिया कि सिंस यू आर ग्रेजुएट फ्रॉम DICT, अ वेरी रेप्यूटेड इंस्टीट्यूशन ऑफ इंजीनियरिंग, कैन यू डिजाइन a jeans material. Vice is looking for some jeans material which is not only a robust, sturdy material, but also it should not wet. क्योंकि एक पर्टिकुलर मार्केट सेगमेंट के लिए लिवाइस उसको लॉन्च करना चाह रहा है, प्रोजेक्ट करना चाह रहा है, एंड दैट एरिया इट रेन्स क्वाइट ऑफ, और इसलिए लोग जीन्स नहीं पहनते हैं, क्योंकि जीन्स अगर एक बार गीला हो गया तो इन ह्यूमिड कंडीशन इट टेक्स लॉन्गर इन गेटिंग ड्राइड, 4 दिन उसको सुखाना पड़ेगा तब जाके वो फिर पहनने लायक होगा. तो instead of that to capture market in that humid area, Levi's wants to design material, a fabric which won't get wet itself. तो आप बारिश में भी पहन के रहेंगे तो कोई ज्यादा आपका कपड़ा डैमेज नहीं हो. तो व्हाट विल यू डू? Okay, so we will start next class from this question itself. भी 2-3 और स्लाइड थे मुझको दिखाने के, लेकिन with that I will take next class. So we will start next class with this question. I would expect that some of you must read or try to gather some information or knowledge from any source that how we can make the clothing material, fabric, non-wetting or self-cleaning.